Okay, are you tired from Adventure 7? I know I am. That's a lot of work. And if you got through that, congratulations. That's some of the hardest work that we do in geometry, and a lot of kids really don't like it. But you persevered and you got through, and good for you. So now what I'm going to do is I'm going to construct a parallelogram. And you're going to be happy to know that in Adventure 8, it is a lot easier. I think, that's my opinion. I think you're going to find it a lot easier. So I've constructed a line here, and I'm going to, oh boy, I don't want to do that. Let's undo that. I'm going to use my parallel line tool to construct a parallel line to it. Okay, I'm going to place points on these lines. I'm going to actually not use those points themselves. Well, yeah, I can use those points. That'd be fine. But I need a fourth point right here. So we're going to place a point on that object. And then we're going to actually need to make another line, and that's going to be actually right here. Boy, I don't want point D. I'm going to delete that one. Okay. Now what I need to do is I need another line that's parallel to this line, right, AC, that goes through point B. And is that parallel? That just does not look parallel, does it? Maybe in my eyes. We'll check it out here in a minute. But anyway, we're going to intersect here those two lines. So where D meets that line there, and we have an intersection. So now it just doesn't look parallel, but we're going to verify real quick those lines are parallel and make sure I haven't done anything wrong here before we move on. That has a slope of 3.24, and that does too. So that's really what I was hoping to see. All of the slopes are the same. So let's take those slopes off real quick. Now what I really wanted to do is construct a polygon, okay, that connects these 4 points. Because the polygon is what we're interested in, not really the lines, the polygon itself. And I'm going to just take those lines off. Take the lines off, and we just simply have, you know, this shape here. So what I should have constructed, and what I think I've constructed here, is where I can change A, B, or C, but no matter what happens, these lines are going to be parallel. Let's take a look and see if that's the case. Okay, we're going to just measure those slopes, and on the slopes of the opposite sides, and we're going to see if we just get those same measurements no matter how we adjust it. So right now we've got 0.06, 0.06, 0.72, 0.72. Looking good, looking good. And yes, it looks like I can move B and they'll stay the same, C and they'll stay the same, and A are parallel under all circumstances. So we have constructed a nice little parallelogram. We'll take those measurements off. So this is a parallelogram no matter how I leave it, okay? So now what we're going to do is we're going to try and prove somehow that the opposite sides are congruent to each other. The opposite sides are congruent to each other. So in order to do this, we're going to draw a diagonal. And now we're going to be very glad that we learned about transversals. Okay? And remember what we learned about transversals at parallel lines. There's a specific thing about alternate interior angles. Okay? So let's see if we can find a pair of alternate interior angles that are created where these lines, you know, intersect, where this line intersects. Well, if I think about these being the parallel lines here, AC and DB, then the transversal crosses across them. These angles are opposite, and they are interior. They're inside of AC, and they're opposite of that transversal there. So let's measure those angles. Something very interesting going on. We remember that alternate interior angles, oops, let me try that again. Alternate interior angles are always congruent. So we should find, boy, I always do it the wrong order. We have the same exact measures of those angles at all times. We see this measures 45.2 and that measures 45.2. Ooh, that's good news, right? And so we know these two angles are congruent. And what about these angles, well, if we think of CD and AB as the parallel lines, then this would be an interior angle of those two parallel lines, and that would be the alternate interior angle of those two lines. So let's see if we can measure this one successfully. C, D, A, and, oh boy, which one should I go first? B, A, D. There we go. And let's pull those measurements out. So, we're verifying. We actually already know that alternate interior angles of parallel lines are always congruent. But we can see it again here inside of a quadrilateral, right? That whatever this angle measures is going to be the same as that angle. Whatever this angle measures is going to be the same as this angle. That's kind of cool. I'm going to create here a triangle, right? And what I'm going to do is I'm going to just make a copy of that, right? Of this triangle. Oh boy. Let me undo that. Sorry about that. So what I'm going to do is I'm going to make a copy of this little triangle right here. Okay, let's try that again. I want to try this one more time. Here we go. From D to point B. To take point B. Oh, my mouse acting goofy. Point A. Not working. All right, let's try this one more time. Polygon. D, B, A, back to D. That's the polygon, and it should be showing up down here. A triangle, right? So if I hit escape, sometimes when this thing is buggy, the best thing to do is look and see if anything is highlighted. Right now, nothing is highlighted. And then sometimes instead of touching the stuff here, it's better to just simply touch the definition in the algebra side. So I want to make a rigid polygon, okay? And that's going to help me right here. I'm going to go ahead and make a copy of that, because then I can move that copy. So this right here represents that triangle, okay? Here we go. We're going to do a polygon again one more time, and we're going to just make the other side of this quadrilateral, okay? And then I should see a second triangle down here now. Yeah, that's the one I just created, polygon 4, okay? And now I'm going to make a copy of that triangle. Okay, not working. All right, let's make sure we got nothing highlighted. One more time. Rigid copy of this triangle. There we go. Okay, so now in essence, what I'm going to do is I'm going to prove that this triangle is congruent to that triangle. So how am I going to do it? Well, let's get the text box out here and let's type it out. Okay. Moving slow right now. I'm sorry, everybody. Probably doing way too much at the same time. Recording my screen and processing all this. Writing a magazine. Doing everything I possibly can at the same time. We'll see if that pops up. But essentially, what I'm going to be saying here. Alright, here we go. What I'm going to be saying is that this angle, BD, so I can say angle BDA is congruent to angle, and that would be let's see, BDA is congruent to CAD, right? CAD by alternate interiors, right? And then I can say that angle CDA, so an angle CDA is congruent to angle, and instead of CDA, I've got to go to BAD by alternate interiors as well, right? So if this angle matches this one and this angle matches that one, the third thing I want to mention is that this side right here matches that side right there, right? That's AD. So I would say AD is congruent to AD by the, remember what that was when we said something is congruent to itself? Well, that is the reflexive property. I always think of the reflection in the mirror when you look at yourself. The reflexive property, okay, of equality, or of congruency in this case, because we're talking about being congruent. So we would say by the reflexive property of congruency. And we can click, well, we're not quite done. We have a little step more. So now we can say that by angle, side, angle, okay, angle, side, angle, we know that, what do we know? That triangle BAD is congruent to triangle AD, CDA. Okay, I gotta make sure those letters are in the right order. If I go wrong side here, B, long leg to A, across the hypotenuse, and then end here with omitting the short leg, I need to do the same thing here. Long leg across the hypotenuse, omit the short leg. So I went BAD is congruent to CDA. All right, so if we proved that these two triangles are congruent, well, what do we know? We know then, this is where it gets kind of good, okay, because we can prove, therefore, let's see, CD is congruent to BA by CPCFC. Remember, congruent parts of congruent triangles are congruent, but now we're not, oh, actually these are triangles still. So we can say triangles are congruent, that's fine. But figures works as well. Anyway, and DB is congruent to AC by CPCTC. So we have really laid it out there. The whole thing is done. Let's take a look at this logic, okay? And I'm going to kind of draw as I walk through it real quick with my pen. We're going to just kind of draw it. So here we have BDA, okay? Angle BDA. All right, so the first step I'm saying is BDA, which was represented down here as this angle, right? That it is congruent to CAD, which is represented as this angle here, right? Those two angles are congruent, and the reason is they are alternate interiors of these two parallel lines. If I look at the transversal, they're on the opposite sides, right? And then we have angle CDA, which is this angle here. I'm going to mark this one with 2 marks. This means it's a different measure than the one with just 1 mark. With CDA is congruent to angle BAD, that's this guy down here, but these guys have the same measure, so I'm giving it 2 arcs too to show that they're equal, okay, or congruent rather. So we know that they are congruent by alternate interiors as well. And we know that this side right here, I'm going to mark it with a single hash there. Let me erase that. Let's try that again. Try to get a straighter line. Okay, so that mark right there, we call that a hash mark. And it is congruent to this one here by the reflexive. Why? Because it's the same side, right? So it is congruent to itself. So now by, angle over here, this angle and that angle, right? This side and that side, and this angle and that angle, by angle, side, angle, angle, side, angle, angle, side, angle, we know the 2 triangles are congruent. And now that we know the 2 triangles are congruent, the corresponding parts of congruent triangles are congruent. So HI is congruent to FE. Ooh, wait a minute. CA is congruent to BD, right? And that, let's see, also, CD is congruent to AB. We've got, do we have that right? CD to BA, that's fine. And DB to AC, yeah, that's fine too. So it's all written out there fine. Hopefully you followed the logic and can work this one out yourself. So what you want to do, make it up yourself, write it out, then make a move note where you demonstrate your understanding of it.